The Sun will meet a similar fate, where its outer layers of gas will eventually escape into space. The stars have always held profound significance for humanity, but our understanding of vast celestial bodies, such as galaxies in the farthest reaches of the universe, has only recently advanced. The James Webb Space Telescope, eagerly anticipated as a game-changer in astronomy, has surpassed expectations. According to American astrophysicist Neil deGrasse Tyson, its recent revelations have expanded the boundaries of our expectations, offering a unique and unparalleled perspective on the cosmos. Neil deGrasse Tyson asserts that the James Webb Space Telescope, with its groundbreaking capabilities, has allowed us to glimpse ghosts from the past. The telescope's recent discoveries have astounded the scientific community, revealing unprecedented insights into the cosmos. Tyson believes these findings have ushered us into a new era of astrophysics, providing a gateway to a previously unattainable window on the universe. Since commencing science operations during the summer, the James Webb Space Telescope has illuminated some of the most remarkable discoveries in the space domain. The telescope, with its infrared vision, recently delved into Titan's obscure atmosphere, uncovering what is believed to be a methane sea, sand dunes, and clouds. This $10 billion observatory has also captured breathtaking photographs showcasing incredible depth and vivid color, including images of the first galaxies that emerged less than 500 million years after the Big Bang and the stellar nurseries of the Carina Nebula. Neil deGrasse Tyson emphasizes the telescope's ability to exceed the expectations of its design. As director of the Hayden Planetarium in New York, he says the James Webb Space Telescope represents a new era in astrophysics, capturing images that will improve our understanding of the universe. Launching in December 2021, the James Webb Space Telescope is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. NASA Administrator Bill Nelson praised the telescope's ability to probe more than 13 billion light-years. The telescope's near-infrared camera, NIRCam, allows scientists to show some of the Hubble Space Telescope's most famous objects. Neil deGrasse Tyson emphasizes that the power of X-ray telescopes reveals galaxies hidden by dust or clouds, revealing beautiful spiral galaxies and deep images. Tyson underscores the significance of studying galaxies from the early cosmos, emphasizing that the light from the most distant galaxies represents the oldest light in the universe, having traveled for 13 billion years. The James Webb Space Telescope was purposefully designed to detect infrared light, addressing a gap in the space-time continuum that hindered Earth from receiving high-quality data from the early cosmos. This unique feature allows the telescope to capture images from the earliest stages of star and galaxy formation, as ultraviolet light transforms into longer wavelengths over the expanse of space that has existed since the Big Bang. The telescope's ability to transmit breathtaking images from the early universe has revolutionized our understanding of cosmic evolution. Tyson remarks that as the James Webb Space Telescope captures infrared light, it allows us to observe galaxies that formed more than 13 billion years ago. This technological marvel has not only changed our understanding of the beginning of the universe, but also our understanding of the planets in the solar system. Tyson calls it a gateway that leads us into a new era of astrophysics characterized by high-resolution, high-quality data. This raises a good question. Given the size of the universe and the millions and billions of years it takes for their light to reach us, how can we make the way we see it? In the celestial bodies since ancient times? Tyson questions the existence of these objects despite how long it takes for them to travel long distances. The incredible size of the universe and the speed of light of 2458 meters per second is the depth of this view. New images from the James Webb Space Telescope could change our understanding of the origin of the universe. Tyson compares these images to a fingerprint of all the matter present in the observed galaxies, explaining which chemical elements are present and which correlate with a pattern of the universe's expansion. Talk turns to unexplained UFOs after the White House reveals little information. Although subsequent observations have failed to reveal any signs of extraterrestrial activity, the James Webb Space Telescope has played an important role in unraveling the mysteries of the universe. Among the telescope's surprising discoveries is the discovery of distant galaxies in unexpected deep-field images. These massive galaxies, nearly the size of the Milky Way and full of old red stars, challenge theories of the early universe. The discovery, made in a study based on the first data transmission from this telescope, contradicts previous observations from the Hubble Space Telescope. The newly discovered galaxies, which appear as small red dots due to their great distance, challenge astronomers' expectations of the first universe. These older galaxies, with red stars indicating their age, are in contrast to the younger, bluer galaxies seen before. The James Webb Space Telescope, designed to find distant galaxies, surprised astronomers when it discovered old red stars and galaxies more than 1 billion years old. According to Professor Joel Leha, the author of the study, the unexpected findings lead to a reevaluation of the theories of life. The discrepancy between Webb's observations and previous models highlights the need for new ideas to explain the rapid formation of these massive galaxies after the Big Bang. Astrologers have the challenge of making sure these different views match real-world reality before revising established theories. The attempt to understand these collections leads to new insights into the mysteries of the first world. The mechanisms known to govern local star formation, such as the relationship between the star's mass and gas composition, have little global relevance. Of the past, these discoveries provide an exciting challenge to our understanding of the formation of stars in the early universe and provide a unique and fascinating perspective. As part of the Cosmic Evolution Endeavor's early release science program, the Webb Near-Infrared Camera (NIRCam) has captured images of faint galaxies. Soon, astronomers will point the Webb mirror at these galaxies to collect their light. Describes the spectrum of the incoming moon and describes the chemical and physical properties of its origin. Scientists are being forced to revise their view of the early universe just months after the first observations from the Broad Observatory. The unexpected discovery of massive galaxies contradicts 99% of the galaxy's previous models. This difference challenges scientists to rethink their theories about the formation and evolution of galaxies. Meanwhile, the James Webb Space Telescope is producing a stunning view of Stephan's dark quintet of galaxies, revealing this cosmic region to be vast and terrifying. Further studies with the James Webb Space Telescope and the Atacama Powerful Millimeter/Submillimeter Array ALMA have revealed confusion between the 5 brightest galaxies in Stephan's 5 constellations. NGC 731b, known as the Disruptor, creates a massive shock wave the size of the Milky Way when it explodes into the space between 4 nearby galaxies. This energy wave triggered the recycling of hot and cold hydrogen clouds, creating a level of drama never before imagined. Eamon, co-investigator and astronomer at the National Radio Astronomy Observatory, suggests that the sight of a molecular cloud piercing through intergalactic gas and causing upheaval is both rare and not entirely understood. The data indicate a significant advancement in comprehending the dynamic behavior and tumultuous life cycle of molecular gas clouds in Stephan's quintet at IN. An even more peculiar revelation: researchers have identified a substantial bundle of gas near the quintet, gradually disintegrating and forming a separate tail of heated gas. This unusual occurrence may signify the presence of a young galaxy, introducing yet another intriguing element to the cosmic spectacle unfolding in this distant part of the universe. Situated between 39 million and 340 million light-years away, the shock waves experienced by Stephan's quintet are typically generated in front of an object moving faster than the speed of sound through a gaseous medium. In this case, NGC 731b is tearing through space's windy material at 800 kilometers per second, or 500 miles per second. The shock wave and its interaction with the atmospheric environment provide historical insight into the complex dynamics of this region of the world. Earth-shattering discoveries made by the James Webb Space Telescope not only challenge current theories, but shed light on complex and fascinating phenomena that occur throughout the vastness of our universe. These findings encourage scientists to reevaluate the fundamentals of the evolution of the universe and encourage further exploration of the mysteries around us. Furthermore, due to the high level of recycling in this chaotic environment, many crazy activities lead to what Appleton calls accidental creation. When the shock wave meets the mass resistance, it forms a line of heated hydrogen gas between the 2 ice clouds, creating a strange phenomenon. Imagine a bullet traveling through a cloud, leaving an annular trail. One of these structures resembles the tail of a young galaxy. The simulation shows the dissolution of a large cloud of cold molecules in a superheated atmosphere, which undergoes a continuous cycle between hot and cold phases. Although the exact nature of these changes is still under investigation, the team concluded that atmospheric recycling occurs due to the length of the tail compared to the dispersion time of the cloud. The team's future work is to use dynamic probes to track the movement of all the gas around the shock wave. This approach allows accurate determination of airflow rates and heating or cooling processes as the shock wave travels through the region. While these recent revelations are telling, they also reveal a great deal of undiscovered territory. Importantly, our knowledge is partial and we are asked to uncover the untold aspects of this story and a suspicious situation given control of the James Webb Space Telescope. Neil deGrasse Tyson showed his desire to lead.